rahmatullahi wa barakatuh. We will continue explaining Chapter 1, Decimal Numbers, Addition and Subtraction, Part 4. At the end of this period, students will be able to use the system to determine a point knowing its coordinates, or to determine the coordinates of a given point, recognize the abscissa of a point on an axis, define an orthogonal system x prime x, y prime y of origin, recognize the orthogonal projections of a given point on the axis, and find the coordinates of a given point in the system by using orthogonal projections, locate a point knowing its coordinates in the system, recognize the four quadrants of the plan with respect to the system, characterize several points on the same straight line that is parallel to the axis of the system, find the coordinates of a given point by using a grid paper. Please prepare the following materials. Coordinates of a point in a plane. Activity. Please pause this video and try to solve the activity. Solution. Draw the number line of origin O. This is the number line. Locate a point A that is +1 and B is -3. What do 1 and -3 represent for A and B respectively? 1 and -3 represents for A and B respectively the abscissas. Draw another x perpendicular to x prime x at O. This is the axis that is perpendicular to x prime x. The two formed axes are called the orthogonal system. So x prime x and this axis which is perpendicular to it are called the orthogonal system. The orthogonal system coordinates of point. Elements in this plane. Look here for the system. The two perpendicular lines are axes. These two lines, they are axes called orthogonal system. Together they are called orthogonal system. The horizontal line is the x-axis or abscissa axis. The horizontal line is x-axis, or we call it abscissa axis. The vertical line is y-axis or ordinate axis. This axis is y-axis or ordinate axis. The intersection point between these two lines is the origin, which is O. So O is the origin. Any point in the coordinate plane is represented by a pair of numbers. So any point on this plane is represented by pair of numbers, x and y. Always x is the first, okay, and y is the second, where x is its abscissa and y its ordinate. X and y are called coordinates. So together they are called coordinates of a point. Orthogonal system is called coordinate plane. Example. Given the 2 points A and B, fill the adjacent blank. Point A, abscissa x, ordinate y. What is the abscissa of point A? It is -2. Ordinate of point A, it is +3. Abscissa of point B, it is 4. Ordinate of point B, it is 0. Application. Given the 2 points C and D, determine the abscissa and the ordinate of each given point. Please pause this video and try to solve the application. Solution. Abscissa of C is -3. Ordinate of C is 8. Abscissa of D is -2. Look here, it is the first. Ordinate of D is -4. So always abscissa is the first and ordinate is the second. How to find the coordinates of a point? Now if we have a point on the plane, how to find its coordinate? To find the abscissa of A, draw from A parallel to y prime y-axis. It cuts the abscissa axis x prime x at point M. Look here, from A, to find its abscissa, we draw a line that is parallel to y prime y. It cut the x prime x in point which is called M. the abscissa of A is -3. M is called the orthogonal projection of A on x prime x. So when you make a perpendicular on a line, it is called the orthogonal projection. To find the ordinate of A on y-axis, you draw from A parallel to x prime x. Now from A we draw a parallel line to x prime x that cut the ordinate axis at a point N. Now the ordinate of A is what? Is +2. And N is called the orthogonal projection of A on y prime y-axis. So the coordinates of A are -3 +2. Application. You have 3 points. Given the adjacent figure, find the coordinates of the points E, M, and N. For point E, look here. We draw parallel here and parallel here. It is about +2 and 3. So E, 2, 3. Point M, it is 2, 0. Why? M has no ordinate. Y equals 0 since it is on x-axis. So when the point is on x-axis, then its ordinate is equal to 0. N is 0, 3. Now N is on y-axis. Then its abscissa is equal to 0. Now how to locate a point? Locate a point A, 4 - 3. First of all, recognize that the abscissa is x equal 4 and the ordinate is y equal -3. 2. Draw at x equal 4 a line parallel to y prime y. And draw at y equal -3 a line parallel to x prime x. The intersection of the two drawn lines is the point A. Look here. Example, locate B, C, and M on this orthonormal system. B, 1 - 2. Look, 1 - 2, this is a point B. Point C, 3.5, 0. 3.5, 0, this is a point C. Point M, 0 and 3, this is a point M. Application. Plot the points A, C, and M. Please pause this video and try to solve the application. Solution. Look here, A, -2 - 3. C is 5, 0. M is 0 - 4. Points on the same straight line that is parallel to the axis of the system. Example, locate the points A, 1, 2. This is A. B, 1 - 1, C, 1, 0. All points belonging to the line parallel to the ordinate axis have the same abscissa. Look here. This line is parallel to the ordinate axis. Look for all these points. They have the same abscissa. So if points have the same abscissa, then the line is drawn by them is parallel to the y-axis. Locate these 3 points. Look for these 3 points. They form a line that is parallel to the x-axis. Look for these 3 points. They have the same ordinate. So all points belonging to a line parallel to the abscissa axis have the same ordinate. Example, given the points B, C, H, M, which pair of points are parallel to y-axis if connected? Solution. 1. Pair of points B, C is parallel to y-axis since they have the same abscissa x equal to. Look for point B and point C. They have the same abscissa. So the line formed by them is parallel to y-axis. Point H and M have the same ordinate. So the line formed by them is parallel to x-axis. Show that BC and HM are perpendicular. HM is parallel to x-axis and BC is parallel to y-axis, but x-axis and y-axis are perpendicular. Then BC and HM are perpendicular. Application. Locate the points. Show that AB is perpendicular to BC. What is the nature of triangle ABC? Please pause this video and try to solve the application. Look here at the figure. This is point A, 1, 2, B, 1, minus 3, C, minus 4, minus 3. 2. Line AB is parallel to y-axis. Why? Since A and B have the same abscissa. Line BC is parallel to x-axis since B and C have the same ordinate. But x-axis and y-axis are perpendicular, then AB and BC are perpendicular. AB and BC are perpendicular, then the angle ABC equal 90 degrees, so triangle ABC is right triangle. The fourth quadrant. Definition. This orthonormal system is separated into 4 quadrants. Quadrant 1, 2, 3, 4. The abscissa and ordinate axis define the plan into 4 regions called the quadrants. Activity. Locate the points. Fill in the blank. Fill the table. Please pause this video and try to solve the application. Solution. We plot the 4 points A, B, C, and D. A belong to the first quadrant, B belong to the second quadrant, C belong to the third quadrant, and D belong to the fourth quadrant. Look here. A, abscissa positive and ordinate positive. B, abscissa negative and ordinate positive. C, abscissa negative and ordinate negative. D, abscissa positive and ordinate negative. Then, quadrant 1, x positive and y positive. Quadrant 2, x negative and y positive. Quadrant 3, x negative and y negative. Quadrant 4, x positive and y negative. Application. Please pause this video and try to solve the application. Solution. Point A belong to the third quadrant. Why? X is negative and y negative. C belong to quadrant 1 since x positive and y positive. I belong to quadrant 2, x negative and y positive. K belong to quadrant 4, x positive and y negative. This is your assignment. Summary. Coordinate system. Points having the same ordinate are parallel to the x-axis. If M has coordinates AB, then M belong to quadrant 1. If A greater than or equal to 0 and B greater than or equal to 0. Quadrant 2. If A smaller than 0 and B greater than 0. Quadrant 3. If A smaller than or equal to 0 and B smaller than or equal to 0. Quadrant 4. If A greater than or equal to 0 and B greater than or equal to 0. Find the coordinates of point by orthogonal projection on the axis. Points having the same abscissa are parallel to the y-axis.